So here we have a problem. A breeder of horses wants to fence in 2 adjacent rectangular grazing areas along a river. The river will serve as one of the long sides. No fence is needed on that side, and 600 yards of fencing are to be used. What are the dimensions that yield the maximum area, and what is the maximum area? So before we start, here are the formulas that we will be using. First, we have the general form of a line. AX plus BY equals C. We have area, which equals X times Y. We have the vertex equation, which equals H equals negative B divided by 2A. We have the quadratic equation, AX squared plus BX plus C equals 0. From the problem, they're saying we should find the dimensions, so we're looking for the X and Y value of the perimeter. The maximum area, we will be plugging our Y value into the area equation. So first, we will start with the general form of a line, which is AX plus BY equals C. So as an example, we will look at the graph. We see that we have the x-axis and the y-axis. The y-axis is vertical and the x-axis is horizontal. So to show a better picture of this, you can draw a picture, but here we have shown a model for you. We see that we have 3 vertical fences and 1 horizontal fence. Since the problem said that the river will serve as a side, we don't need to put a fence here. So back to our equation, we saw that we had 1x as the horizontal and 3y vertical fences equals 600, which we found from the problem. So we want to get x alone. We can solve for y, but solving for x will be easier because we do not have to divide by 3. So here we're subtracting 3y from both sides because whatever you do to one side, you do to the other side. So from this, we get x equals 600 minus 3y. So now we have our area equation, A equals x times y, which we already solved for x in terms of y. So we have a function of y equals 600 minus 3y from x times y. So we want to distribute this y into the parentheses to both numbers. So from that, we get 600y minus 3y squared. From this equation, we can find our y value by using our vertex equation, which was h equals negative b divided by 2a. In our case, we're solving for y, so it will be y equals negative b divided by 2a. So from our quadratic equation, we see that ax squared plus bx plus c equals 0. So we see that from our y equation up here, we see that negative 3 is our a value and 600 is our b value. So plugging in our values, we get y equals negative 600 divided by 2 times negative 3, which gives us negative 600 divided by negative 6, which gives us 100 yards. This value is our y dimension. So from our y dimension, we can use that value of 100 yards to plug into our x equation, which we solved for earlier from getting x alone. So from this, we just plug in our y, which was 100 yards. So we have x equals 600 minus 3 times 100, which will give us x equals 600 minus 300, which will give us the x value of 300 yards, giving us the x dimension. So putting both dimensions together, we have 300 yards times 100 yards, which is our dimension. Now, to find the maximum area, we already have all the values that we need. We have our y equation, a function of y, 600 minus 3y times y, and we found our y value, which was on 100 yards. So we just plug the 100 into the y's, which gives us 600 minus 3 times 100, in parentheses, times 100. Since we know that we have to solve the parentheses first, we do so by 600 minus 300, giving us 300 times 100, giving us 30,000 yards squared, which is the maximum area.